Okay, good morning everyone. Today we will learn about image segmentation. Okay, so definition. So what is image segmentation? Partitioning the image into sub images. Okay, definition is partitioning the images into sub images. So why we need it? Why we need segmentation? Need of segmentation. First thing is for accurate information. If you have, suppose this is entire image, okay, the information is available in this part only, okay. So I am taking this part as information, so I am dividing the image sub images, so we get more accurate information and easy to analyze. Okay, easy to analyze. Okay, so how we perform segmentation? How we perform segmentation? How we perform segmentation? So based on two ways, segmentation can be performed. One is by detecting the discontinuities. Okay, discontinuities, and based on similarities. Okay, based on similarity. So discontinuity based means if there is a sudden or abrupt change in intensity values, abrupt change in intensity values of image, at that condition we divide image, we partition the image. Okay, similarity means based on predefined set, predefined set. Okay, based on the predefined set we group the pixels. Okay, we group the pixels and divide them into one part, divide them into one part. Okay, discontinuity based and similarity based. So discontinuity is classified into again three types. Discontinuity is again classified into three types. Identifying the isolated points, detecting isolated points, detecting lines means line detection, isolated point detection, and third one is edge detection. Okay, edge detection. These three are basic discontinuity based segmentation. In similarity we have two types again, thresholding based, region based. Okay, thresholding based. In thresholding we have global, dynamic, adaptive, okay, variable, so many are there. In region we have region growing, region merging, region splitting, region splitting. Okay, this is the way we can perform segmentation based on discontinuities and based on based on similarities. Okay, so basically before performing segmentation or after performing segmentation, we have to follow some rules. We have to follow some rules. Okay, these are important in image segmentation. First one is, if you perform segmentation, so we divide the images into some parts and named it as R1, R2, R3, so on. Okay, like this we divided. So if you combine once again these all regions, we have to get original image. So union of sub images I is equal to 1 to n. We have n sub images. Okay, it must be becomes for original image. Okay, I is equal to 1 to n. Second one, the sub image Ri is connected set means R1 and R2 must be connected, R2 and R3 must be connected. Okay, I said in first unit itself regarding connectivity, adjacency, everything. Okay, revise those things once again. So I is equal to 1 to n. Next, third condition is Ri intersection Rj. Okay, must be pi means there is no common element between these two regions. Okay, for all I is equal to, sorry, for all I and j and I not equal to j, I not equal to j. Next, fourth condition and fifth condition is advanced condition, that is predictor of region I must be equal to true. Predictor of union of two regions must be false. Okay, must be false. These are the 5 conditions which are important to perform segmentation. Okay, segmentation. Let us see the segmentation based on discontinuities. Okay, segmentation based on discontinuities are done by identifying or detecting isolated point. Next, lines, edges. Okay, lines, edges. So it can be done using two ways. It can be done using two ways. Okay, that is first one, using derivatives, and second one is using filter masks, using filter masks, using filter mark. So these filter marks are also known as sharpening filters, which are used we learn in image enhancement, which are we learn in image enhancement special domain, special domain, okay, special domain, okay. Next, using derivatives also we can enhance the images, enhance the images, because what we are doing here, we are highlighting the isolated point line edges, okay. After highlighting, at that part we dividing, okay. So highlighting means similar to enhance only. So these two techniques are used for image enhancement also. Enhancement also. These two questions may be asked in image enhancement also. Explain image enhancement using derivatives, using sharpening filters. Same question you have to write there. Okay. Same questions. Okay. So let us learn about derivatives. Okay, let us learn about derivatives. So what is derivatives? Derivatives are mostly we are use of first order derivative means f dash of x. Next second order derivative means f double dash of x. Generally images are two dimensions. So we are use f of x comma y. F of x comma y. Okay, derivatives. So how can we calculate the derivatives for two-dimension function? So for two-dimension function, derivatives, second derivative is called Laplacian. Okay, Laplacian. First order derivative is called gradient. First order derivative is called gradient. Second order derivative is called Laplacian. So Laplacian is represented with del square of x comma y, f of x comma y, that is dou square f by dou square f by dou y square. This is Laplacian. Okay. Gradient is represented with vector. Del of Laplacian is scalar quantity. Gradient is vector. So for vector we represented dou f by dou x, dou f by dou y. So the magnitude of del is given as root of, so this term is represented with gx, this term is represented with gy, gx square by g suffix y whole square. And for vector, gradient is vector. For vector, we have to represent direction. So direction is given with angle, that is tan inverse of gy by gx. Okay, gy by gx. So partial derivatives are given as first order derivative. Dou f of dou x is given as f of x comma y x plus 1 comma y minus f of x comma y. Okay. Dou f of x comma y with respect to dou y is f of x comma y plus 1 minus f of x comma y. Okay. Next, dou square f by dou x square means f of x plus 1 comma y plus f of x minus 1 comma y minus 2 f of x comma y. Okay. Dou square f by dou y square is given as f of x comma y plus 1 plus f of x comma y minus 1 minus 2 f of x comma y. Okay, these are the partial derivatives. Okay, you have to remember this. Okay, so Laplacian using Laplacian we can identify isolated points and edges, sorry, lines. Okay, means using second order derivative we can identify isolated points and line. Using gradient means first order derivative we can identify edges. We can identify edges. Okay, edges. Let us see one example so that you can understand how we can identify edges and isolated points using derivatives. Okay, a small example. So let us consider the image strip here. Okay, here we have image strip. Okay, so this line is called edge. This is edge. Okay, and these are lines. This is edge and these are lines. And see, this is isolated point, right? These are some isolated point. So using derivative, how can we find out those things? Okay, let us see. So the intensity values are from 0 to 7. I am writing those intensity values here. 5, 5, 4, 3, 2, 1, something. Okay, like that, so on. I write the intensity values. Now I am finding the first derivative. Okay, what is the first derivative formula? F dash f of x plus 1 minus f of x, right? F of x plus 1 minus f of x means we have to finding the difference of these two. Okay, means we have to calculate differences of these two. This one is x plus 1, this one is x. Okay, this one is x plus 1, this one is x. Okay, so now I am finding first derivative. So 5 minus 5, 0. Okay, 5 minus 5, 0. Next, 4 minus 5, minus 1. 3 minus 4, minus 1. 2 minus 3, minus 1. Like that we calculating so many. Okay. like this. Now for second derivative, f double dash is formula is what? F of x plus 1 plus f of x minus 1 minus 2 f of x. So here we have to calculate x plus 1, f x position, x minus 1. So how can we obtain second derivative generally? First derivatives, first derivative, right? This is first derivative. For first derivative, we are performing again first derivative. Means for this value, if you perform first derivative, we get second derivative, right? We get second derivative. Okay. So previously we have here 0, right? So now this is x, this is x plus 1. So minus 1 minus 0, minus 1. Next minus 1 minus 1, minus of minus 1. Both are cancelled. 0, 0, 0, 0, 0, minus minus 1 means plus 1, plus 1. Next 0 minus 0, 0. 6 minus 0, 6. Minus 6 minus minus. Minus 6 minus 6. So 12. 0 minus of minus 6 is 6. Like that we have to calculate second derivative. Okay. Second derivative. So derivative means f of x minus f of x. So this is x, this is x plus 1. Okay. Now again if you want to calculate second derivative, perform derivative for first derivative. So this becomes x, this becomes x plus 1. Okay. Like that. You have to calculate first derivative and second derivative. So from these values, how can we say the edges and isolated points are available? Observe here, observe this strip now. Whenever there is a negative number and left and right side of negative numbers are positive, then that point is called isolated point. Isolated point. Observe here. And again same here also we get minus 4 and both sides are positive values. Both sides are positive values. At that condition we have one more isolated point. Isolated point. Okay. Now how to identify lines? Identify lines. If there is a continuous zeros between positive numbers, okay, continuous zeros between positive numbers, we called it as line. We called it as line. Okay, line. Okay. Now how to identify edges? This is edge, this is edge. How to identify edge? Edges are identified using first derivative. Whenever there is a negative numbers, we call them as edges. Okay, we call them as edges in first derivative. Okay. Now using mask, using sharpening filters or masks, filter masks. How to identify? How to identify point and edges, lines. Okay. First, isolated point. For isolated point, the mask is this one. 1 1 1 1 1 1 1 minus 8. Okay. Isolated point mask. This is the isolated mask. Next, for line. Generally, lines are how many types? Horizontal, vertical, plus 45, minus 45, right? This is plus 45, this is minus 45. Vertical, horizontal, right? For this, the marks are like this. For these marks are like this. Minus 1, minus 1, minus 1, 2, 2, 2, minus 1, minus 1, minus 1. This is for horizontal line. To identify horizontal line. Next, minus 1, minus 1, minus 1, 2, 2, 2, minus 1, minus 1, minus 1. Okay. This is for vertical line. Okay. This is for vertical line. Next, plus 45. 2 minus 1 minus 1 minus 1 2 minus 1 minus 1 minus 1 2. This is plus 45. Next, minus 1 minus 1 2 minus 1 2 minus 1 2 minus 1 minus 1. This is minus 45 degrees. So this is the mask, filter mask, to identify the lines. Okay. Next, edges. So before knowing the edges, we have three types of edges. Step edge. Step edge. Step edge means it looks like this. How to identify in image? It looks like this. This is image. Complete box. Okay, complete box. This is one type of edges. Next, ramp edge. Ramp edge means it looks like this. It looks like this. In image, how it is possible? See. Entire black. 0 means we said entire black. This is one, so pure white. And here I am using gray color. Gray. Okay, here here I am shading another color. Mostly we use gray color. Okay, gray color. This is gray color. Okay, this is black. This is white. White. Okay, this is one more edge. Ramp edge. Ramp edge. Next, roof edge. Roof edge. Roof edge means it looks like this. Okay. So it first black, next somewhat gray and white, gray, black. Okay. Black, gray, white. Again gray, again black. Like this, the roof edge is available. Okay. Roof edge is available. Now filter marks. Let us see first type of filter mask, that is robot filter mask. Robot mask, we call them as robot mask. Robot mask is given as -1 0 0 1 0 -1 1 0. Okay, combinedly we have to give. Okay, combinedly we have to give. This is a robot mask. Okay, next privet mask. Privet. PREWITT. Privet mask. Okay, in privet mask we have horizontal, vertical, 45, -45. So it is given as -1 -1 0 0 0 0 1 1 1. This is horizontal. Okay, next vertical. This is vertical. Next +45 0 1 1 -1 0 1 -1 -1 0. This is +45. -45 1 -1 0 -1 0 1 1 0 1 1. This is +45. This is privet mask. Okay, next Sobel mask. Sobel mask. Sobel mask is given as same vertical, horizontal, etc. -1 -2 0 0 0 1 2 1. This is horizontal. Next vertical, -1 -2 -1 0 0 0 1 2 1. This is vertical. Okay, next 0 1 2 -1 0 1 -2 -1 0. So this is +45. Okay, next to -45 means -2 -1 0 -1 0 1 0 1 2. Okay, this is -45. So these four are Sobel marks. 1 2 3 4 Sobel mark. These four are privet masks. These combinedly two are called robot mask. These are three basic filter marks used for edges. Okay, how to detect these things? We have to perform convolution, already explained in image enhancement. Convolution, the filter mask is convolution on input image. If that value becomes 0 means we identify whatever edge or line or point. Okay, if that is not equal to 1 means there is no edge or line or point. Okay, this is common for any filter mask, common for any filter mask. Next, some other edge detectors, other edge detectors which are not in our syllabus. Okay, those are Mar-Hildreth mask or LOG mask. Okay, second one is canny edge detector. Canny edge detector, Mar-Hildreth or log mask or canny edge detector. We have two types. Just remember these name and I will give LOG mask. LOG means Laplacian of Gaussian. Laplacian Laplacian of Gaussian. Okay, Laplacian of Gaussian. So the mask is given as 0 0 minus 1 0 0 0 minus 1 minus 2 1 0 minus 1 minus 2 16 minus 2 minus 1 0 minus 1 minus 2 1 0 minus 1 minus 0 0 minus 1 0 0. Okay, this is the LOG mask, Laplacian of Gaussian mask. Okay, so this is the discontinuity based segmentation using derivatives and using mask. Next, similarity. In similarity, first one is thresholding. First one is thresholding. So what is meant by thresholding? So thresholding means we dividing the images into two parts. So the thresholding function is given as g of x is equal to 0 and 1. If original image, we have to set some threshold value t. So this is the basic intensity thresholding, okay, or global thresholding or basic intensity thresholding. Intensity thresholding. So 0 is called background point. Background point. This is foreground. Generally, image consists of foreground and background, right? So using thresholding, we separating background and foreground. So 0 is called foreground, 0 is called background, 1 is called foreground, where T is threshold level. Okay, T is threshold level applied on entire image. Okay, applied on entire image. This is global thresholding. That if T is constant, we called as global constant. Next, variable thresholding. Variable thresholding. Variable thresholding means T is variable. It is not constant. Okay. This T is variable. Local or regional. Local or regional thresholding means local or regional thresholding means T is variable. T is variable and T depends upon neighborhood property. Neighborhood property. Okay. Neighborhood property of x comma y. Okay, of x comma y. At any point x comma y. What is neighborhood property? We have 4 neighbor, 8 neighbor, diagonal neighbor, right? It has to follow the condition, these conditions also. That is local or regional thresholding. Okay. Next, dynamic or adaptive thresholding. Dynamic or adaptive thresholding. Dynamic or adaptive thresholding. T is variable, means this T threshold level is variable and depends upon spatial coordinates x comma y. Okay, spatial coordinate x comma y. Okay. Last one is multiple thresholding. Multiple thresholding. So multiple thresholding means g of x comma y, we have 2 types of thresholding levels. So if f of x comma y is greater than t2, t1, t2. Next, if f of x comma y is less than or equal to t1. Okay. This is multiple thresholding. Multiple thresholding. These are the basic thresholding types. After defining the function, how to perform the thresholding, because we learn the definitions. So we have to split the image. How to perform segmentation? First step is steps. Steps to perform thresholding. Threshold based segmentation. We just learned the definitions only. So now steps to perform threshold based segmentation. So first step is, first initiate yourself 1t. Okay. First initiate with the 1t. Next, after defining this t, first split the image into 2 parts. split the image into two parts using T. Okay, so we get two parts, G1 and G2. Okay, G1 and G2. Now we have to do compute mean of intensity values. Compute the mean of intensity's value. Calculate mean of intensity values of G1 and G2. Notate with M1 and M2 respectively. Okay. Set predefined value T. Divide image into two parts. Image into two parts using T as G1 and G2. Calculate mean intensities now. After calculating mean intensities, now set the new threshold value. New threshold value is average of these means M1 and M2. And again split G1 and G2 using this T, new T. Like that, we can divide subimages like this. Okay. Repeat this step 4 until required subimages available. Okay. Next, region-based segmentation. Region-based segmentation. It is classified into three types. Region growing, region splitting, region merging. Okay. Region growing, region splitting, region merging. So what is region growing? Region growing is nothing but combining the group of image regions. Means we are joining the sub images like this. So this is one region and we joining one more region and we joining one more region, like that we join the regions. So there is a specific way to perform this operation. Okay. Region growing. So first we define a seed node. Okay. First we define a seed node. Seed node. Okay. Seed node. For this seed node, let us calculate region growing. Set seed node. Okay. Set the seed node. Now from second, after assuming the seed node and select the subregion, check for possible 8 connectivity paths. 8 connectivity paths for the seed nodes. seed node. If any available, link them. Okay. Link them. If any not available, stop linking. Stop linking. Okay. If any available, link them and set new linked pixel as seed node and repeat above steps. Repeat above steps. Okay. Repeat above steps means, suppose consider one pixel. This is seed node. So 8 connectivity, I get one pixel like this. Here 8 connectivity, here 8 connectivity, 2 regions I got. Okay. So I am combining these two. Now this is seed node. These are seed nodes. Now you have to check for this one 8 connectivity, any available or not. Any available or not. Like that, we are growing the region. Okay. This is region based, region growing segmentation. Okay. Region growing segmentation. Now region splitting. In region splitting, we have to follow only 2 steps. For the region R, okay, for the region R, you have to find out the calculate predictor of R. Okay, calculate predictor of R for entire image. If Q of R is true, leave it. Okay, leave it. If Q of R is false, split the region into 4 quadrants. 4 quadrants. Okay, into 4 quadrants. Okay. Repeat the above step for every sub region, every sub quadrant. Okay. Okay, repeat the above step for every quadrant. Suppose now this is R. This is R. I get false. If you get false, we divide it into 4 quadrants. Okay, 4 quadrants. R1, R2, R3, R4. Now for sub-regions also you have to check. If I get true, leave it. For R2 I get false. So again I have to divide into 4 parts. R22, R21, R22, R23, R24. For R3, I didn't get true. Again, you have to split into 4 parts. So R31, R32, R33, R34. For R4, I get true. So leave it. So like that, you have to split again and again. Okay. So you can represent this one in quad tree. So R, first is R. R is split into 4 regions. R1, R2, R3, R4. Right? Again, R2 is split into 4 parts, right? R21, R22, R23, R24. R3 also split into 4 parts. R31, R32, R33, R34, like that. So you have to draw like this. This is called quad tree. Okay, quad tree. So this is region splitting. Region merging is a reverse process of splitting. Calculate Q of Ri union Rj. Okay, Ri union Rj. Okay, if it is true, merge them. Okay, if it is false, leave it. Okay, true means merge, false means leave it. Okay, this is the region merging. So this is the entire segmentation part.